Hello YouTube. Today I'm going to be showcasing this robotic arm that I built. Just a little project I took up this summer, thought it'd be some fun. So yeah, I'm going to be showing some of the components of the build, and then I'll kind of show off some of the things it can do, and then at the end I'll quickly debrief on, the whole process and the things I've learned and all that good stuff. Alright, so I'm going to quickly go over the components of this thing. If you're not interested, just skip ahead, say like a minute or so. Anyways, let's start off with the brains of this operation. That Arduino board right there from the LU starter kit that gives a signal to these MG996R servo motors. I use 4 of them. One's under there, you can't see it. And then another one right there. Those servo motors have 180 degrees of rotation. And then these 2 battery packs right here, each of them hold 4 AA batteries. That just provides the energy and power that this thing needs, because unfortunately a Arduino board can't supply enough power for 4 servo motors. Other than that, we just have some wiring here along with some capacitors. Those just kind of steady the flow of the current through the whole thing, just to make the whole thing not so jittery when it moves. Alright, so originally I actually intended to make this robot shoot a little ball into a mini basketball hoop. I was going to call it the Steph Curry robot, just for a little bit of fun. But yeah, as you can see, there's nowhere near enough torque to throw a little ball 1 foot, let alone from a significant distance to resemble that of Steph Curry. So I thought to myself, what other NBA player could I replicate? And with a big dunk, you know who I'm talking about. No, obviously I'm joking. But when I made this robot, I did actually want it to do something else. I didn't intend to just make a robot that moves with basic code. I wanted to do something a little bit extra, a little bit more, so I thought about it. When we're little itty bitty kids and we look at these robots and we're fascinated by them, how do we want to move it? We're not going to use C++ to code the thing. Kids don't even know what that is. Look, he's confused. You know what they want? You know what kids want? They want a controller. Look at how happy those kids are when they have a controller in their hand. So, that's exactly what I did. Okay, and there we go. A controller. It was actually surprisingly easy to make, especially for that dramatic entrance. But yeah, as you can see, moving the joystick up and down moves the robot up and down, and moving it left to right moves the robot left and right. Pretty self-explanatory. And then if you click down on the joystick, it actually moves the wrist joint to a set position in the code. And then that potentiometer, which is the little dial you see right there, moves the gripper. It opens and closes it. But yeah, unfortunately with the wrist, I just didn't have enough things to make it a free-flowing joint, where I could just move either a potentiometer or joystick and control it to any position I want. So I just had to make it a set position. But yeah, here's some of the things you can do with it. But yeah, now we're just gonna go into the debrief. So yeah, I do want to start off by saying, the robot arm is by no means flawless, which I'll get more into later. But this whole thing was funded by me, so I try to make it as cheap as possible. And without access to things like a 3D printer, it's hard to maintain super good quality. But the whole thing took about $80 in my pocket, so not too bad. And here's some of the code, by the way. There's only about 80 lines of code, so, pretty short. But yeah, like I said, the thing's not perfect. For example, some of the joints can be a bit wobbly at times, which I think was actually a good learning point. I had to learn how to kind of secure things and make things be strong with not so strong materials. Because with the corrugated plastic I was using, it's not the strongest thing in the world. It can be pretty flexible and can warp at times. So I had to kind of work around that. Additionally, I struggled with the gripper joint probably the most. It was just really difficult to make it strong enough to hold anything. Uh, so I had to learn a little bit of mechanics there with the gears and the kind of 4-bar linkage I used. Um, so yeah, that was a learning point. But I think the biggest takeaway from this whole thing was that it kind of opened the doors for me, you know? Because when I first had this idea towards the beginning of the summer, I had no idea how to go through with it. I mean, a robotic arm, like, I didn't even know how to do it. I couldn't fathom it. I couldn't conceptualize it. But, you know, after a little bit of research and just breaking it down to its most fundamental concepts, you know, and learning about the Arduino and the servo motors, you know, things started to come together and it started to make more sense. And then as I started to build, you know, the understanding grew, all the way up to the finished product. So it was really cool to go from nothing to be able to build a robotic arm from scratch, you know, and it was a confidence booster in the sense that the next time I have a project, an engineering project I want to go through with, I'll have more confidence to be able to do it because I know that even if I don't understand how to do it at first, I know eventually I will be able to. And I think that's great. So I think that was the biggest takeaway, honestly, from the whole project. And overall, I'm proud of how it turned out, even if it's not perfect, even if it's not what I first intended it to be. But yeah, I'm proud of it, and I really would like to do more projects in the future. But yeah, if you somehow made it all the way through this video about me babbling on about this project I made, you know, I thank you. But I have nothing left to say anymore, so see ya.